Good morning, everybody. Welcome to the second day of this year's Wireless Congress. We yesterday already had a very good day, I believe, with nice presentations and good interaction, both in the panel discussions of the sessions, but also during the breaks. So I hope that you also enjoyed the day, and even though we are only meeting online virtually, make good contacts, get nice new ideas and nice new questions and problems. For today, we have a split program. The morning will be filled with 3 excellent keynotes, followed by a panel discussion with all the 3 keynote speakers on the future of wireless. And then after the lunch break, lunch and networking break to be precise, we'll go into the different sessions, one on low power wide area network for the whole afternoon, and the other track is split between the session 5 compliance and the session 7 on Bluetooth topics. The keynotes that we'll have this morning are not only reporting about what is already available, but they also shall give an outlook into the future. And one element which is, well, partially still in the future, partially already existing, obviously, is 5G, 5th generation of cellular communication. And the first 2 keynotes go around that. Both with the special topic of using 5G in the industrial applications and industrial markets, which I believe, especially for Germany and for Europe, will be one of the very interesting application fields for 5G. Let me welcome Joseph Barry as a first keynote speaker. Joe is Vice President of Wireless Communications Business Unit at Analog Devices, where he is responsible for the creation and execution of Analog Devices strategy for the full suite of radio solutions for the wireless communication part. Also, in this role, he's responsible for the technology groups of high-speed converters, SDR transceivers, and microwave communications, which, as you know, is quite important for Analog Devices. Before, Joe has served in leadership roles in the wireless communication, consumer, and semiconductor industries for more than 26 years. Originally, he has earned a Bachelor of Engineering in Electrical and Electronic Engineering from University of Greenwich and an MBA from the University of Limerick. So, Joe, it's a very great pleasure having you here and hearing your keynote on a roadmap for 5G implementation in the industrial market. The floor is yours. Thank you.
Professor Sikora, thank you. Thank you very much. Sorry, 1 second.
Yeah, this just was full screen. That was nice.
Okay, sorry. Yep. Okay, so good morning, everybody, and thank you for attending today. What I want to talk about today is, I think there's a lot of interest throughout the conference, obviously, on 5G and its impact both today and in the future, and maybe more specifically in terms of how it's impacting some of the industries like industrial and how 5G wireless is impacting that. So to get started, I'll just do a very brief introduction to my company, Analog Devices. We're the 10th largest semiconductor company in the world, really focusing on this bridge between the physical world and the digital world, where we have to sense many different types of signals. We have to make measurements, we have to interpret those and connect those to the digital world. So those are the problems that we really, as a company, are focused on. in terms of that bridge between the physical and digital world. Obviously, we have a very diverse set of technologies and products focused across many, many different markets. So that's at a top level, that's what ADI is focused on. What I want to move on to is just looking at, when we look at 5G and, what the promise of connectivity in terms of next generation connectivity that 5G can bring, I think it's important to recognize that when we look across many of these markets, like, autonomous transportation, digital healthcare, Industry 4.0, smart instrumentation, some of the immersive consumer applications, all of these markets are in the face of, transformation. And part of that transformation is being enabled with this next generation of connectivity that 5G brings. So I think that's very important to recognize. When we'll just do a very brief history lesson. When we look at the 4G approach, typically how 4G networks were built is, very rigid in terms of how they were constructed. 4G base station, typically a macro base station, and then a very rigid core network that was pretty much proprietary in nature, proprietary architecture. On the spectrum side, very much, the traditional way of using spectrum in terms of, just blast out the RF signal across the entire spectrum. But I think when we look to, what's happening from 4G to 5G, in terms of, there's more radios required. Obviously, that comes with the challenge of more complexity, but within that then comes the opportunity, the increased opportunities that are there. So just very briefly looking at how these 5G base stations are built today, and I picked, there's two main segments of types of radios. One is the mid-band, which is what we classify as all radios below kind of 6 gigahertz, and then there's the high band radio, which are more the millimeter wave radios. But if you take this example of 5G massive MIMO radio, on the spectral side, the technology, in the radio is really focused on how to get to better spectral efficiency. So delivering up to 5x more spectral efficiency through beamforming. So very targeted use of the spectrum to different applications on different users, depending on their needs and requirements. Then on the kind of left-hand side of this slide, there's a lot of change, and I'll talk more about this specifically because I think it's important to the overall context of the presentation today. Really is what's happening as well at the kind of network, starting at the core network, and as it comes out to the radio access side. There's a lot of transformation there. A lot of it today is still very much in the 4G space, but it's transitioning now in 5G to more virtualization and cloudification of the core network and the extension of the radio access side as well. So those are going to be very important transformations in 5G. So, when we look at what's deployed today in terms of current 4G and 5G deployments, they're very much architected and structured on this fixed radio access network, which is kind of the legacy of how networks have been built before. Very much rigid, very much designed to proprietary requirements. But what's happening now in future, in some and future deployments of 5G networks, is the introduction of a vRAN, or virtualized radio access networks. And that's a very important change, and I'll explain in more details as we go through the presentation. But essentially, it's a disaggregation of the hardware elements, like the radio unit, the digital unit, the central unit, and the core network. And the advantage with virtualized RAN is essentially this aggregation of hardware and the software elements that are required to actually build and implement and support a network offer great potential in terms of the types of emerging use cases that want to really exploit 5G potential. So that's important, underpinning kind of technology transformation in the network that's going to, I think, drive a lot of change in the future. So looking at 5G and why it can make so much more possible, I think it's important to recognize that there are three core aspects of what's delivered in 5G at the technology level. The first one is this EMBB, Enhanced Mobile Broadband. So this is what we all traditionally think about in terms of, just higher bandwidth and larger capacity downloads for a typical use case like mobile subscriber use cases. The second aspect of 5G is this massive machine type connectivity. So supporting, hundreds and thousands of connectivity to the network on machines. So that's going to enable lots of applications around smart homes, smart city, and industrial applications, which I'll talk a little bit about in detail later. And then finally, the third aspect of 5G is this URLLC, which is this ultra high reliability plus ultra low latency. That will allow, I just picked some examples here of applications, drones, driverless cars to be very, very safe in terms of their end application. One of the other very important features that 5G offers is network slicing. And this really provides the potential now on a go-forward basis that, you can match the network requirements to the application needs. So in this slide, I've given an example of where you slice the network in 3 different ways. So you provide one slice that's got guaranteed throughput. So that might be a consumer application that requires high bandwidth or a VR or AR type application. Another slice can provide balanced latency and throughput, for example, on an application that might be required around logistics or automation and industrial applications. And then finally, you can offer a third slice on the network, which is offering very, very low latency slice. So that might be dedicated to healthcare or an automotive type application. And the very attractive piece of the network slicing is it's dynamic. You can dynamically allocate resources depending on the loading and then the demand from the end applications. So I want to look just briefly at, I think this is important to underpin the kind of future direction and why, I feel so excited about the opportunities in 5G. So I just want to speak to some of the business opportunities that are emerging in 5G. So this is some research that's published by Polaris Market Research. It looks at 5G private network business opportunities. So you can see that they're forecasting that by 2027, there's going to be over $8 billion of opportunity in private networks. They've also outlaid kind of the timeline and which industries might adopt those in which time frame. So initially, the expectation is that ports, airport, logistic hubs, those are expected to be, and I think there's early signs that those are the first movers in terms of this rollout of 5G private networks. Then following that comes factories and warehouse applications. And then finally, when you start to break into greenfield installations, on university campuses or other types of campus. So, really, really tremendous opportunity that can be enabled through the use of 5G technology in the private network sector. This is some additional research that IHS has published, again, looking at the 5G private network opportunities. And this just gives you some sense of scale across the many different industries that have potential to deploy 5G radio and 5G core network technologies. Across container ports, oil refinery, manufacturing, construction, warehousing, wind farm, oil rigs, etc. The list is quite long, but the exciting thing here is that the use of this technology can drive very substantial economic progress and economic output, and it's projected to generate over $5 trillion by 2035. And you can see the breakdown here across, obviously, manufacturing is going to be the most substantial segment within that, but there are still other significant segments like transport, construction, utilities, and mining. So enabling the factories of the future with 5G technology. If we look at a world where people and robots need to coexist, enhanced connectivity through 5G will certainly improve that human to machine interaction. It will reduce the risk of accidents and it will drive efficiencies and cost savings. I think that's the cost saving and efficiencies is instrumental in terms of securing the investments required to deploy and develop this technology. So we'll see increased efficiencies, improved margin profitability. I'll give some example of some research on that in a moment. It'll also focus on better reliability and reduce lag time in terms of production throughput. And obviously, a concern for all industries is security. So delivering high secure networks integrated across and within multiple factories and campuses is also critical. So looking at how 5G might deploy and the models of deployment for private networks, I look at this in terms of three options that are available. The first option is really looking at a local radio as an extension of a service provider's infrastructure within the network slicing. So we have a service provider providing a slice to a dedicated application where they control and orchestrate the slicing. Model B is essentially a Model A plus some additional service provider infrastructure that's deployed locally. So example, some core or cloud capability that's provided locally to provide more capability. And then finally, the third model is this standalone local deployment with dedicated spectrum. And this is an interesting one. I think we're seeing cases of this emerging certainly in countries like Germany and Japan, where dedicated spectrum is coming online. That's only available for licensing in the private network use cases. So that's how I see the private network rollout deploying. Obviously, multiple cases there. This is an interesting research that AIB undertook, looking at an automotive factory opportunity that would deploy 5G cellular technology into that industry. I think the bottom line here is, the ROI on the investment of upgrading the factory or bringing your factories online with 5G technology, is greater than 9. And obviously, the impact to the bottom line and the margins is almost reaching 5%. So, that's a tremendous opportunity in these types of industries, really, to improve the ROI and drive improve gross margins and profits. So that's very encouraging. That said, there are 4 major challenges, I think, in terms of private network mobility and how it gets deployed. The first being there's no apparent or clear or preferred go-to-market or leadership available today. 70% plus of known deals do not include telecom providers. There's the system integrator, or the SI gap, which is holding adoption back currently. The SI gap exists between the telecoms and the managed services that are required by the end applications, be they industrial or otherwise. Then the MSP operation scalability, support from the NOCs for managed services is not available currently, and that's something that needs to be addressed. And then finally, the other challenge centers around EPC sourcing for full service integration. So how do we achieve the kind of scale that's required there that delivers the demands and the cost efficiencies that are ultimately required to bring this 5G technology into these types of industrial applications, for example? So those are some of the challenges. I feel confident that, there's a lot of transformation and change happening in the micro and macro ecosystems that are focused on these types of industries and the wireless technology that will be delivered to them. And I think, the strengthening and vibrance of those ecosystems is really going to be critical to tackling some of these challenges. So I see the journey, along, when we reflect on 5G, it's really a journey of evolution. And what I mean by that, and I think it's really kind of getting into a point now in 2020 and 21 where it's reaching, a level of maturity that it moves into, from wave 1, which was really, for the last 3 years, it's all been about getting to 5G readiness, focused on basic access. So kind of more of a continuation of, just wider bandwidth delivery through, from a transition from LTE to 5G. But as we look across that journey, what's driving this, what I call a second wave, which is really this cloud native approach and cloudification of the network. So when you look at, what's transforming and impacting the journey, I think it's really 4 factors. One is spectrum availability, and we see increasingly more and more spectrum becoming available, which is exciting. Also focus on the regulations that are more favorable and the policies that are more favorable to the deployment of this technology is encouraging. The ecosystems, both micro and macro level ecosystems that are required, I think they are starting to mature, they're starting to gain scale. So that's a vital ingredient to drive this transformation. And finally, obviously, the bottom line, monetization. These business cases that I've talked about across multiple industries, it's very important that they hold true and that the scale is developed to drive the efficiencies and the profitability that's required to get the return on those investments. So as we enter wave 2, I'm very excited looking into where we are at the end of 2020 and looking into 21. I think we really start to see large scale engagement on Industry 4.0, which focusing on massive connectivity, etc. So we're really on the cusp of that change, and I think that's a very exciting future for all of us. What role does my company, what role does ADI play in terms of the ecosystem? I've mapped out, just an example of 5G ecosystem engagements, and I think it's useful because, one of the central parts of our strategy is that, we recognize that, when the technology like 5G is so transformational in terms of its impact to many, many, many different industries, not just the communication infrastructure industry, but to many of the industries I talked about, like digital healthcare, industrial, consumer, etc. So the ecosystems that are required to service and address some of the challenges in these markets is essential. So obviously we're very collaborative at the silicon and IP level within the ecosystem. We work across many of the standard orgs and participate actively in many of those working groups. Many of the products that are required in 5G will require new manufacturing capability in the supply chain. So bringing in contract manufacturers that are capable to develop and manufacture these products is important. Developing more scale on radio unit suppliers, working with some of the 5G system integrators, those that will take the hardware and the software and integrate the network. And then finally, the telecom operators that are operating the networks. So just very briefly, I want to focus on, ADI primarily focuses on the ORU, or the radio unit technologies. So some of the challenges there that the industry faces are, firstly, on building these 5G radios. There's pretty steep challenges in terms of the size and the weight requirements, the power and the costs of those. So, some of the traditional way of trying to build these with FPGAs is uncompetitive versus the established kind of traditional OEMs. So our strategy really is focused on enabling market-leading ORU technologies. So investments in merchant silicon solutions that reduce, the thermal challenges, simplify the RF and radio design, reduce and eliminate some of the costly FPGAs. Also, help to really drive the technology at a point of performance and cost that really is enabling. Second major challenge is time to market. So, you look across the portfolio and SKUs that you need in terms of, the different form factors of radios, from small cells to macro to massive MIMO. Then you look across the SKUs of all the different bands and configurations, single band, multi-band, tri-band requirement. So very complex product SKUs required. And a sparse ORU vendor market exists today. So we're really focused on how we enable a thriving ORU ecosystem. So we're contributing to that by offering complete, flexible reference solutions for all BTS form factors: small cell, macro, MIMO, single, dual, tri-band, etc. And all of this is built on a common hardware and software platform that really provides scale and aggressive options for getting to market quickly with these new 5G radio requirements. And then finally, to wrap up, I really want to stress that my belief that there's a very exciting future ahead for business with 5G, and it's certainly the most disruptive technology yet. And when we look at the broader adoption, I think it has many exciting implications for many types of industries. I think for mobile operators, the growth in these new markets can mean additional revenues and increased investments in building out more and more 5G infrastructure. I think the pace, I've been in this industry for many, many years. I think the pace of innovation is remarkable in 5G. I've never seen this pace before, and I think we're just at the beginning of what's possible in terms of 5G and its potential. I want to stress to the audience that for a lot of this potential to be realized, a vibrant and flourishing ecosystems are essential, to really be able to realize that full potential for business and society as a whole. And then finally, 5G has the capabilities to enable, these next generation wireless factories and so much more, and really help to transform industries across the board. So with that, I would like to thank you.
Yeah, and with this, we would like to thank you, Joe. The applause is yours, even if there's no audible applause. Thank you very much for sharing your view. I believe that due to the time, we should maybe shift the questions which have been raised in the Q&A section afterwards to the panel discussion, because I also had the impression that they might be relevant not only for you, but also for the other speakers. So maybe we shift them to there. Please allow me a very short question. You mentioned ADI's role in this ecosystem. You also mentioned on the other side that more and more functions are moving to the cloud and into the backend. How do you see this development for a company like ADI?
So obviously, our strategy is very much focused on the radio. Radio challenges in 5G are still very significant, but we collaborate very closely with the broader ecosystem, which is developing, many aspects of the cloudified side of the network, both in terms of the hardware and the software. And it's vitally important, because you just can't build a radio in isolation. You have to work in terms of its interoperability, its integration, the kind of features. So we're very active in terms of our participation there. And also the mindset that, this human-centric approach is very important when we look at ecosystems, and, having, common approach to challenges, common approach to problems, that's our strategy and our mentality when we partake in these ecosystems. It's really trying to develop the vision and what all parties in the ecosystem want to achieve ultimately as a goal, and being very clear about how we collaborate to get there. I think they're the essential ingredients of success in how we operate and how companies need to operate in these ecosystems, because it can become very complex very quickly if you imagine an ecosystem that exists in digital healthcare, an ecosystem that exists in industry, and then you have a connectivity ecosystem, and you've got interdependencies across multiple ecosystems. So we're obviously very conscious of that, and I think that's what's required, I think, to drive some of these transformations.
Okay, thank you very much for this answer. Now we have 30 seconds left to move into the next room. So thank you very much again, Joe. It really was a pleasure. We'll see you again at 12:20 in the panel, please.
Thank you.
And now everybody from the audience, and maybe also you, Joe, will be moving to the presentation of Josef Blanz from Qualcomm for the second keynote. For this, we have to move into the next room. So please jump in there, and looking forward to seeing you in the room for the second keynote.